Hi, my name is Dan, and this video is the start of a short series of videos that I'm going to do on creating binary decoders in digital logic circuits, which in itself is the start of quite a long journey that we're going to go down towards creating a simple CPU. Um, so this process of creating a CPU is broken down over I think it's going to be 10 playlists that are going to appear on this channel, and each playlist will deal with one small element of this CPU. The first six playlists will all be pretty generic, things that will be applicable in all sorts of different situations anyway, and the last four will become very specific towards the particular CPU design that I'm going to show you. So it's a long journey that we're starting on, but this short series is all about binary decoders, and in this one I'm going to develop a simple one-bit binary decoder, which is a very trivial circuit actually. And in all of these videos, what we're going to do is we're going to use this software called DigitalWorks. There'll be a link. You can get it for free. There'll be a link in the description below. Also, in the description below, there will be a roadmap of where we're going in the larger context. Um, so, yes, and the other thing to say is that, and each video or pretty much each video will result in us creating a macro in DigitalWorks, which we can then use in later things. I encourage you to get DigitalWorks and to actually do all this for yourself, because it's a great feeling when you get to the end and you've created a computer out of basic logic gates. And in fact, that's what I'm doing is that I will just use basic logic gates, apart from one tiny place where I need a little bit of a wrinkle. But otherwise, I will explain everything that's going on. And by the end of this larger set of videos, if you follow through the whole thing, you should be able to understand the basic workings of a simple CPU and therefore understand computers in a much deeper and more fundamental way than maybe you have done before. That's a lot of philosophizing there. So let's crack on and do a binary decoder. And in fact, we're just going to do a one-bit decoder. We're going to have one input and two outputs. So what a binary decoder does is it takes a number of inputs, however many bits you want for your input binary number, and it then gives you a number of outputs, each of which is discrete. So for a 2-bit binary decoder, you'd have two inputs for your binary number, and you'd have four lines on the output, and only one of which can be active at any one period in time. For a 3-bit decoder, you'd have how many is that? That's 8, and for a 4-bit decoder, you'll have 16. And over this series of videos, we're going to do each of these in turn, and you'll be starting to build up a set of parts that you're going to be able to use through this. So a one-bit binary decoder is really, really simple. And again, what we're going to do in all these videos is we're going to actually, because we're creating them into a macro, what we're going to do is going to create the macro first, and then we'll do a circuit which tests the macro, and it's worth making sure you test everything. Because you need to know where your problems are if things haven't gone right. So I'm just going to put some tags down. This is going to be my input and a couple of outputs. And you maybe are able to figure this out for yourself. I'd be quite pleased if you could. This is our input, and so when our input is 1, then this output will be 1, and when our input is 0, then this output is going to be 0. So I'm going to just quickly label these. That's a bit bigger than I wanted. Input, input, and that's going to be so that's 1 and that's 0. So I'm It's kind of inverted from maybe where I want it, but I'm going to write this as outputs, outputs, um, 1, 0. So um, I put it like that so that the 1 to 0 matches up with the fact that that's the 1 and that's the 0 output. Okay, so we're going to go to the template editor to turn this into a macro. So we're on template editor. It's the default macro here has got a box on the word macro. I'm just going to highlight that. So you'll find sometimes in the template editor, if your box is already selected and you try and select something inside the box, you can't. You have to deselect and then select nothing inside the box. And I'm going to call this a 1-bit decoder. About 10 points. It's, yeah, it maybe could be smaller than this, but this is fine. I'm going to put a couple of pins in here. In fact, obviously we need 2 outputs. And it's so there's this kind of weird thing between binary numbers and discrete outputs is that the usually with binary inputs we'll go from the most significant bit down to the least significant bit. But with discrete outputs, we'll probably want to count from left to right. So we want to go 0 to 1 in this case. So I'm just going to label these as input and output. Bring it down to 7 points. Input. And then I'm just going to copy that and change that text. So I'm going to call this output. And this, unlike in the main circuit, this is going to be 0, 0, 0 to 1. Now, when we start to have larger numbers of outputs, it'll make more sense why I've got the dots to show the spread. Okay, so turning this into a macro, we need to close that. Yes, we're on the right tool. So let's connect the input together. Associate with tag. And we need to make sure we get this right. Output 1. So I want output 1, which is the right hand side here. And then finally output 0. Okay, so I'm gonna save this, and I'm gonna start my own folder for the macros that I'm gonna use. In fact, I've got a testers folder there, and I've got a my macros folder here already. So I'm gonna call this. So I it's tempted to call it a 1-bit decoder. In fact, I'm going to call it decoder 1 bits because this means all the decoders will be grouped together in alphabetical order, so it'll be easier to find them. And then I'm going to make a separate circuit to test it. I'm going to open the parts center. Come on, where's the parts center disappeared to? This is because I'm zoomed in. Over here now, I want to go to please bear with me. This is just going to take a little while to find my stuff because it's actually on OneDrive, which just makes it even more confusing. Windows C? No, that's not what I want. Up. Can't go up any further. Users. That's me. And this OneDrive. There we go. Computer fundamentals. Digital works. Finally, we get there. My macros. Decoder 1-bit. I'm going to pull the parts center over here, so it's going to be more useful when we zoomed in, maybe. And we're just going to chuck an input on a couple of outputs on this to test it. Let's zoom back in because it makes it easier to see. So I'm going to put a interactive input and a couple of LEDs on the output. wire them up. I'm not bothered about neatness for this because it's just a tester. And simulate and run and I'm intrigued by the fact that that hasn't gone white. So 0 should give you a 0 output, 1 should give you a 1 output. So already I've seen there's a problem here. So let's have a, we're going to double click in here to actually have a look inside. And I do know what the problem here is. It's because effectively it's kind of weird because it's about inputs and outputs, and the fact that this input is connected directly to this output and there isn't a gate in between. So I'm going to go back to this is kind of a digital works issue rather than a logic circuits issue. Circuit has changed to current circuit, no. I'm going to open the macro up, and I'm going to chuck in a couple of buffers in this line just to make this happen. Zooming in is a really good idea, but sometimes issues. Actually, I was going to put two NOT gates in a row, but let's actually do it in a more traditional way. Put an AND gate in and wire the two inputs together. So this is just for the sake of making sure that our input is not directly connected to our output and there is in fact a gate in between them. Because I'm wiring the two ANDs together, that effectively acts as a buffer. There is no simple buffer in digital works, unfortunately. Right, so I'm going to save that and we'll try this again. Files, oh no, not save as, just save files, save. Hopefully this will now work. So let's get a new circuit. We've got our decoder 1-bit, which we can pull in. We've got two LEDs on the output. So that thing that alerted me to the fact that there was a problem, when you put an LED in like this, it kind of is pink rather than red or white. And before you're simulating, it tends to settle for what it thinks might be the outputs. I'm not quite sure whether it goes to dark pink or light pink, how it decides that. But that's an indicator that something might not be wired up correctly. So hopefully this is now going to work. We're simulating, I'm going to use the direction thing. And so for a 0 input, the left-hand output was working, and for a 1 input, the right hand is working. We can flip between them as much as we like. We have a 1-bit decoder. So I'm just going to, I will save my testing circuits. So I'm just going to save that inside. Let's go up, my testers. And I'm just going to call it decoder 1-bit test. Save. There we go. So that's a simple 1-bit decoder. And that's it from me for now.